Hi, welcome to the Mathemagic channel. Today we look at how we can solve x squared minus x cubed equal 36. Let's try it out. Alright, so since this is a cubic equation, we probably expect to find three solutions, whether they're real or complex. And so we're going to try and find those out. A good idea is to try and see if we can find one that is a obvious solution or a solution that you can guess. So if you think about square numbers are naturally smaller than cube numbers. So when we say x squared minus x cubed equal 36, that's quite awkward. If you think about a positive number, for example, 5 squared is 25. And if you were to subtract 5 cubed from that, then you get 25 minus 125, which is a negative value. So the only way that you're going to get 36, which is a positive number, is if the number that you're squaring is negative and it turns into a positive, and then after that you subtract a negative number cubed, which is going to work out nicely for you. I'll give you some examples. If you're to do negative 1 squared minus negative 1 cubed, then you notice that you'll get 1 minus, and then negative 1 cubed is going to be negative 1, which will give you 1 plus 1, which is 2, which is a positive value. So that only happens because we took a negative number and we squared it and then subtracted a cube from it. If you're to take negative 2, so worth investigating a little bit further, negative 2 squared minus negative 2 cubed, negative 2 squared is going to be positive 4, and negative 2 cubed is going to be negative 8. So in this case, we'll get 4 plus 8, which is 12. And if we were to do this with negative 3, we'll probably get closer to our desired result of 36. That might even be the right answer. So minus 3 squared minus 3 cubed. So 3 squared is 9, and then 3 cubed is 27. So minus 27, and we get 36. Oh, wow, 36 is good. That's what we want. Okay, so we found a solution, and that's going to be quite useful, actually. So let's take this solution of 36, which we found by investigation, and use it to move further in the problem. So we have a nice first solution here, which we found by investigation, which is negative 3. Okay, if we can plug negative 3 in here and obtain 36, we can rewrite this cubic as negative x cubed plus x squared minus 36 equals 0, and perform what we call a long division. And the long division should be with the factor x minus a, so x minus x1 in this case. And the solution being negative 3, we can divide this equation by x minus 3, which is x plus 3, and that will be a factor of the equation. So this value x plus 3 is a factor of the equation. And so we can divide the equation by x plus 3, and we should find a nice quadratic. And trying to solve that quadratic, we should find the remaining two solutions, whether they're real or complex. So let's perform a long division. So we're going to write x cubed plus x squared, and we don't have any x's, but maybe a good idea to write plus 0x so you don't get confused when you do your long division, minus 36. And we're going to divide this using long division, dividing it by x plus 3. So the technique for this is to think about how many times x fits into negative x cubed. We can say it fits negative x squared times. And so you multiply this by the bracket here. So you can say negative x squared times x is negative x cubed, and negative x squared times 3 is negative 3x squared. So if we do this first line minus the second line here, minus x cubed minus x cubed goes away, and then x squared plus 3x squared will become 4x squared. So we can say we have plus 4x squared here, and then we can drop the 0x down just like we would if we did a normal long division. For our next step, how many times do we fit x into 4x squared? We can fit it 4x times. So we can say 4x times x, which is 4x squared. Your goal here is to make the numbers exactly equal to each other so they cancel out. So when you ask yourself that question, 4x times x is 4x squared, and that's going to cancel the 4x squared out very nicely. exactly like normal long division. And then 4x times 3 is 12x's, so plus 12x's. Remembering here to do this line minus that line so that we get 0x's, 0x squares, sorry, and then 0x minus 12x is going to be negative 12x. And then we can drop the minus 36 down. And so if we're doing this properly, on our last line, we should get a remainder of 0. So this is your time to double check and make sure that you do have a remainder of 0. So how many x's fit into negative 12x? Well, negative 12 times x will give you negative 12x. So we can say negative 12. Negative 12 times x is negative 12x. And negative 12 times 3 is negative 36. And just like we wanted, we have a nice remainder of 0 here. Now, as you get used to doing these long divisions, you will be able to do them faster and faster, just like you learn long division normally. So this process shouldn't take you a very long time once you get used to it. So it's a good strategy. So we can say that our polynomial p of x is equal to this factor of x plus 3 multiplied by this quadratic here, which is negative x squared plus 4x minus 12. And we're going to have to try and solve this quadratic equation now. Okay, so if we try and solve negative x squared plus 4x minus 12 equals 0, that's a bit awkward because there's a negative in front of the x squared. So if we shift everything to the other side, we could say it's the same thing as solving x squared minus 4x plus 12 equals 0. And if you think about factors of 12, well, 12 has factors 6 and 2, positive and positive. And that's kind of sad because 6 and 2 would work very well for negative 4 if you had negative 6 and positive 2. But in its current form, we can have two positive factors of 12, like 3 and 4, 6 and 2, or 12 and 1. None of these add up to negative 4. And if we take the negative factors of 12, negative 3 and negative 4, that's negative 7, negative 6 and negative 2, that's negative 8. There's nothing really that factorizes here. So factorization is not going to work for us. And so if factorization doesn't work, probably a good idea to start looking at the discriminant delta, which is b squared minus 4ac, and try and use the quadratic formula. In this case, we have the a value, which is 1, the b value, which is negative 4, and the c value, which is 12. So if we look at our discriminant delta here, delta is equal to b squared, so b squared will be negative 4 squared, so we can say 16 minus 4 times 1 times 12, and 16 minus 4 times 12 is 16 minus 48, which is equal to negative 32, and therefore there are no solutions in the real numbers, no solutions. And that's kind of difficult, but that's only in the real numbers. Probably we can find solutions in the complex numbers. So with that information in mind, let's rewrite our delta value as the square root of 32i squared. So that's for the square root of delta, which is going to be the same thing. So when you look at square root of 32, you have 16 and 2. So we can say that that's 4 root 2 for the square root part. And then we can say that we have I, so 4i root 2, as we do the square root of I squared. And that'll be good for the square root of negative 32 and give us two complex solutions. So when you finish your quadratic equation, you can always say that x, so in this case, since we used x1 for negative 3, we can say x2, x3, so our last two solutions are going to be minus b plus or minus the square root of delta divided by 2a. So to finish this question nicely, we can say that x2 and x3 are going to be, so minus b, so you see the b value is negative 4, so minus b is going to be 4, and then plus or minus 4i root 2, which is the square root of delta, so this is using the quadratic formula, 4i root 2 divided by 2a, so in this case that is 2, and so dividing everyone by 2, we can say that that's equal to 2 plus or minus 2i root 2. And to finish your question, you can list your solution set here and say x1, x2, and x3. So we do have 3 solutions to this cubic equation. We can put the real solution first to say we have -3, and then we'll put our 2 complex solutions. So 2 minus 2i root 2, and then the other one, which is 2 plus 2i root 2. And just like that, we have found the 3 solutions to this beautiful cubic problem. Thank you so much for watching the Mathemagic channel, and we shall see you on the next video. Please don't forget to like and subscribe. Bye bye!